Hello students, my name is Shashank Shekhar and we are doing a crash course on chemistry for the upcoming JEE exam. And so today is our last day. So today we will be covering the last chapter, that is analytical chemistry. So let us move to this chapter. So the chapter is called as analytical chemistry. So we will be basically doing the analytics of both organic and inorganic. If we look at the JEE syllabus here, then we have the organic part, which includes the uh, conformation test of many of the functional group. Then we have some preparation of the organic compounds. Moving to the inorganic part, we have some preparation for inorganic also, like the more salt here and the potash alum. Then we have the confirmatory test for the both cation and anion. So let us see what the chapters looks like. So this is the chapter in a more detailed manner. So first we will see the test for unsaturation and different functional groups, that is unsaturation, alcohol, aldehyde, ketone, carboxylic acids and amines. Moving on to the preparation, we will see the preparation of some inorganic compound and preparation of some organic compound. At last, we will do the test for anions and cations, which will include preliminary test and confirmatory test. So let us start our topic. So this is the thing that we have here. One question is asked, but if you see all over weightage of it, which looks like a 4 marks, but many questions are asked from here, but it does not look like that it is from the uh, analytical chemistry, but it is from there, like the Benedict's reagent and the reagents which are not given in NCRT are given in this analytical part. So student get confused that why this is not mentioned in the NCRT, so why it is asked, and some questions like that arise in your mind. But for that thing, here is the solution, that you studied the analytical part, studied all of the analytical part. Some of the PDFs are also available by the NCRT site. You can get it from there. So today we will see those things, the all those material in a more you can say concentrated form. So here is the starting one. So first we will see the test for the unsaturation. The first one, unsaturation test, you have seen in this NCRT also. So we have the bromine water test. What do? We do is we take the compound and react it with the bromine water. If the bromine water turns from reddish orange to colorless, then it is having a unsaturation, or you can say it is having a double bond or a triple bond. So it can be double bond or a triple bond. So this test you know about this, but the next text you must have not heard it in the NCRT or seen in the NCRT, but it is there in the analytical part. So it is the Bayer test. So what do? We do is we take the KMnO4 solution and we treat it with the compound that we have. And if we see that the color changes from purple to colorless, so the color of KMnO4, you know it very well, it is purple in color. So if it changes from purple to permanganate, colorless, then it is a the group is having a functional group which can be a double bond or a triple bond again. So the reaction equation looks like this. So it is a kind of redox reaction. Here MnO4 minus changes to MnO2, means the oxidation state of Mn, which is initially you can say 4 to the 8 minus 1, which is plus 7, changes to 2 to the 4, that is plus 4. So the oxidation state changes from plus 7 to plus 4, so this is getting reduced, and this one is getting oxidized as it is getting oxygen added to its self here and here. So we get diol here as the product of this reaction or the Bayer test, and you can say that okay, unsaturation is present there in the compound. Next we have the steric ammonium nitrate test. So this is the steric ammonium complex that we have. It is a octahedral complex of serenium. Now what do? We treat it with the alcohol. So this is a test for alcohol basically, and steric ammonium nitrate turns into, means the complex turns into red complex. What happens is that this is replaced by this ROH here, plus we get this ammonium nitrate. So the formation of this red color confirms that there is an alcoholic group present. Next is the iodoform test. So the iodoform test is for two kinds of group. The first one is this one, which we have seen earlier. This is CH3CHO, okay, or you can say CH3CO, and this R can be anything. So this is Not correct. So either for this group or for this group. So for both of this group, this iodoform test is positive. So what do we take is potassium iodide plus sodium hypochlorite, that is Ki plus NaOCl, or we can also take potassium iodide and sodium hypochlorite, because these both are same. Sorry. So this is the solution that you can take. This is potassium hypoiodide. It will look like this, KiO hypoiodide O3. Yeah. So if you treat it with KiO3, which is nothing but the product of upon the reaction of these two, you will treat it with excess amount. Then treating it with NaOH at the last in the presence of base, basically I am saying, you will get your iodoform, which is having a yellow crystal, means which is having a yellow color. Or you can take the initial reagents also, that is sodium hypochlorite plus potassium iodide, and treat it with this alcohol. Okay, one more thing here, that yes, it should have a base also here, so base should be also added to this solution for the reaction to take place. Then you will get again your yellow crystals of iodoform, plus you will get this this carboxylate anion for both cases. Now next is the Lucas test. So this is for the differentiation between primary, secondary and tertiary alcohol. So we have seen the text earlier also. So what do is we heat this compound with ZnCl2 and HCl, and upon the depending upon the rate of reaction, we classify them as the primary, secondary and tertiary. And the conformation is seen, means the physical appearance of the test is seen by the formation of two layers in the reaction medium. So if it is formed within 1 minute, then it is said that okay, this is a primary alcohol. If it is formed between 1 to 5 minutes, then it's a secondary alcohol. And tertiary alcohol, tertiary alcohol, this reaction does not happen. Sorry for this. Okay, so this is all about this Lucas test. So primary alcohol do not separate, secondary alcohol separate within 1 to 5 minutes, and tertiary alcohol separate immediately. So this result suggests that there is some kind of SN1 mechanism is going on during this reaction. Why? Because the tertiary is giving quickly. So it must be a kind of, you can say, because there is substitution here, the OH group substituted by Cl. So it must be going through a SN1. So the stability of carbocation is more for tertiary alcohol. So we get this reaction immediately, which is confirmed by the formation of two layers in the reaction medium. Next is the ferric chloride test. So it is for the phenolic group basically. So we take the compound and we treat it with ferric chloride, that is FeCl3, and we get a violet complex. So it is also a kind of octahedral complex. Octahedral complex. And you can say that it is a low spin complex. So this is from the coordination part. Okay, so we get the violet color at the indication that okay, we have the phenolic group present in the solution. Next we have this functional group phenolic for test, that is done again by the phthalene dye test. So we what do is we take the solution of this compound and we treat it with conc H2SO4 plus phthalic anhydride. So this reaction takes place. So it is a kind of, you can say, this is a electrophilic aromatic substitution reaction. So you can see very clearly that a kind of electrophilic aromatic substitution reaction is going on, and 2 moles of this phenol is included in this. Okay, so 2 moles of this react with this one, and an electrophilic aromatic substitution takes place, and you get this compound. Further, on treatment with NaOH, we get different color for different kind of compound. So if it is O-cresol, so O-cresol looks like this. Then we have pre-cresol and then M-cresol. Sorry, M-cresol and then P-cresol. So O-cresol give red color, M-cresol give bluish purple, and P-cresol give no color. Then again we have this catechol. So catechol looks like this. OH, OH. So it gives blue color. Phenol gives pink color. Okay, and resoricinol gives green fluorescent. So this all can be identified and specified also, that which kind of OH is present, whether it is cresol, whether it is catechol, or simply phenol. You can identify with this phthalate dye test. Now what is the next thing is to notice here is that if we treat with this color compound with this excess ONOH, then we will get a colorless compound again. Okay, so this is also characteristics of this phthalate dye test. Next, we have this 2,4-DNP test, that is dinitrophenyl hydrogen test. So it is done for aldehyde and alcohol both. So what do? Is we treat this aldehyde or ketone, means or the organic compound we get with an alcoholic solution of 2,4-DNP or dinitrophenyl hydrogen. Now, the appearance of yellow color, orange color and orange red precipitate confirms the presence of carbonyl group. If the precipitate does not appear at room temperature, warm the mixture. So if the reaction does not occur, you can warm the mixture. Then if it is aldehyde or ketone, then it will show colors, precipitate of 3 of this any color. And if it does not show any of 3 of this, then of course this is not an aldehyde or ketone. So it is a kind of nucleophilic substitution reaction on carbonyl. So we have seen this reaction. So we are taking a derivative of ammonia. So this is ammonia. So this Z is replaced by this group, and we're reacting it with the carbonyl. So we have seen this reaction earlier also. So it is basically a nucleophilic substitution reaction with ammonia derivative, in which Z is equals to this whole group. Next, if we have a solution aldehyde, so we have to confirm whether it is aldehyde or ketone. We can have 3 tests or 4 tests, we can say. One is Benedict's, Tolvin's, then we have the filling, and then we have this, say, Skiff's test. The first is the Benedict's here. So Benedict's and fillings both are based on the same kind of principle, that is the formation of this cupric oxide. So only the complex that we are taking for the reaction is different. So the Benedict's reaction, Benedict's test is you can say a modified version of this fillings test, and it is much more appropriate, in which we do not have to take 2 solutions. We will take only 1 solution here, that will be a complex of sodium. Okay, so it looks like this. So this is a complex of copper, which looks like this. So how it is formed? It is formed by the reaction of copper sulfate and this Na3C6H5O7 plus 11H2O, and it will form a complex of copper acetate, means copper anion acetate, and we will react it with the aldehyde. If it react with the aldehyde, then it is giving brick red precipitate plus the carboxylate salt. Okay, now if you move to the filling test, then we have a different kind of complex formation. So what do we take? We take the filling solution A, which is again aqueous copper sulfate solution, but the solution B is alkaline salt of sodium potassium tartrate. So this is the thing. So and what do we do? We react it with the copper sulfate solution, and we get this copper tartrate complex. So initially we have sodium potassium tartrate, and when we react it with the copper sulfate solution, the both sodium and potassium are replaced by this copper, and we get copper tartrate complex. Again, the formation of this brick red precipitate indicate the presence of the aldehyde group. So this is the reaction that we have, and again the RCHO is converted into carboxylate ion. So this is the filling test. Next we have the Tolvin's test. So we have seen all this test earlier also, but since this is in the analysis part, I am teaching it one more time. So what do we take? We take alkaline solution of silver nitrate and ammonia. So upon this addition of the silver nitrate and ammonia in alkaline solution, we get this complex here. Now if we treat it with the compound that we get, then we will get a carboxylate ion plus 2Ag, which will be a kind of silvery color. So what it is? It is a layer of silver metal on the inner surface on the test tube, which shines like a mirror. So this is the confirmation that okay, aldehyde group is present in the solution. Now this was all for the aldehyde. Now we will move to the last of the aldehyde, which includes the Skiff's test. So what is Skiff's test? Is we treat the aldehyde group with alcohol plus Skiff's reagent. So this is the structure of Skiff's reagent. So it is an organic compound, and appearance of pink color indicates that okay, that we do have this, say, aldehyde. So the basic rearrangement of this reaction is that, so this compound is going from the benzonoid form to the quinoid form upon with treatment with this aldehyde. Okay, so this is the thing that we have here for the aldehyde. Now if we turn to carboxylic acid, so we have some simple tests. So I have put all this test in one page only. So we have the litmus test. So since it is acid, it will convert the blue litmus to red, the most simple one. Then we also know that upon treatment of acid with sodium hydrogen bicarbonate, we have a CO2 release, which is having a brisk effervescence. Okay. Also means we can have the ester test. So we treat the carboxylic acid with alcohol and sulfuric acid, and then we get ester, which is identified by a sweet smell, because esters are having a sweet aroma. So you should remember this. So if you are asked a question like this, an organic compound is treated with so and so, and you get a sweet smell, then you can say that okay, it can be your carboxylic acid due to the formation of ester, means some kind of ester formation is going there. So this is about the carboxylic acid. Now next we will move to the organic compound containing nitrogen. The first one is for the amine group, specifically aliphatic or aromatic primary amine. So it can be only aliphatic or aromatic, but it should be primary amine. Then and only then you will get your reaction. What are the reagent? The reagent is alkaline solution of chloroform. Okay. So this is the chloroform, this is the alkaline, and you know this reaction, this is given in the NCERT also. So we get RNC, which is having a foul smell or a rotten egg smell here. So we have seen this reaction earlier also. So if the amine is present in the reaction or in the solution, then it will react with this CHCl3 and it goes through carbene formation to give you this RNC, which is isoalkyl isocyanate, which is confirmed by the formation of fall of a smell, that is having a having a smell of rotten egg. Next we have the azodite test. So this is both for the phenol and case of aniline also. So what do? Is we first prepare our diazonium salt by reaction of aniline with NaNO2 plus HCl. Okay. Now what do? It we treat with this alkaline solution of beta naphthol. Okay. So we do this reaction. So sorry, not beta naphthol. This is a different test. Okay, sorry for this case. So this is a phenol and this is the aniline. So if this diazonium chloride on treatment with this phenol, then it gives you orange dye, and if it is aniline, then it gives you yellow dye. So this is for a different reaction. So we'll see it, what is this beta naphthol later on. Next we have some preparation of some inorganic complex which are common. You should remember the formula at least. So this is the equation that we have. So we treat the potassium sulfate with ammonium sulfate in water. Okay, then we get this kind of complex which is called as potash alum, which we call as fitkari also in Hindi. So this is the method for preparation of this potash alum. Next, the most famous one is the Mohr salt. So the Mohr salt is prepared by FeSO4 plus ammonium sulfate in water. Then we get this ferrous sulfate. So this is the reaction for the preparation of Mohr salt. Next, let us look at some preparation of organic compound. So this is the preparation of beta naphthol. So what do? Is we take phenol azo. This is the formation of this complex, that is yellow precipitate. Okay, so this is the previous one. So it is mainly used for the detection of aniline group. So what do? Is we treat the aniline with diazonium chloride. Again, it leads to the formation of our diazonium salt. Then we treat this diazonium chloride with the beta naphthol in the presence of NaOH. Then we get this orange red dye here. Okay, so this is a thing. So this is about the organic compound which is having phenol azo beta methyl called. Okay. Now let us see the preparation of another compound that is called p-nitroacetanilide. So we have this acetanilide here. So what do? Is we simply use a nitrating mixture and convert it into this para-nitroacetanilide. So how this acetanilide is formed? So those who don't know, it is treated the this aniline is treated with your acetic anhydride simply in the presence of a base, and sorry, in the presence of acid, and we get this reaction, and or we get this compound. Then on further treatment it with nitrating mixture, we get a para nitro substituted acetanilide. Again, this is the second reaction, third preparation. Okay, so we take diazo ammonia benzene, and then we treat it with this HCl. So what does happen? So this bond breaks and diazotization takes place to form the diazonium salt and aniline. Now we treat this diazonium salt with excess aniline again to get our para-aminobenzene. Okay, so these both are the reverse reactions of each other. So what we are doing is we are preparing this diaminobenzene with this aniline and diazonium chloride, or we can revert this back by treating it with HCl again. And how do we prepare this acetanilide? So this is the reaction. This is para-acetanilide. Okay, so this is repeated. Sorry. So this was some preparation of organic compound. Now we will start with the inorganic analysis. So first we will start with this anion test. So two cases arise. So if the salt is water soluble, so first we are doing the weight test here. So how this extract is prepared for weight test. So if the salt is water soluble, we simply dissolve the salt into water and we get our extract, that is the water extract. But if the salt is water insoluble, then sodium carbonate extract is prepared. And how it is prepared? So what do? So we heat this sodium carbonate with this salt and we get our sodium carbonate extract. So there is some kind of laboratory preparation, and it is not important for your JEE syllabus. Okay. Now to confirm the presence of CO3 minus ion, either an aqueous solution is taken. So if the if you have to test this for CO3 minus, then it is a special case that we have to take the water extract, or we have to take the salt itself. We cannot take this sodium carbonate extract in case of CO3 minus, like a confirmatory test. So let us start our preliminary test. So what do? We prepare the solution of dilute sulfuric acid with salt, and we see the inference, that is the gas that is released. So if we get a Brix effervescence, then it is carbonate simply. Then H2S, which is having a pungent smell, and we can say a smell of rotten egg smell. Okay, then we get our sulfide, which turns lead acetate paper black. So it can be ascertained more with treating it with this lead acetate paper. Then we get our lead acetate paper turns into black. Again, if we have this SO2 and then the SO2 gas release, then SO2 gas release is confirmed by the pungent smell like burning sulfur, which turns in acidified potassium dichromate. So this both have kind of burning smell, but the difference is that the first one turns the lead acetate paper into black, and the second one it like burning sulfur, which turns acidified potassium dichromate green. So this turns this potassium dichromate into green. So if it is paper black, then it is H2S, and if it is green, then it is sulfate. Okay, Sa2 gas. And what are the possible anion? So this is for sulfide and this is for sulfite. It is SO3 minus. Now if we have the brown fumes, which turns this acidified ammonium iodide solution into blue, and this potassium iodide solution also contains starch, that is NO2 gas is released and nitrite ion may be anion may be present. If the colorless vapors are formed, then with the smell of vinegar and the vapor turns this blue litmus red, means this is the acetate ion and this is the CH3COOH gas. So this is the preliminary test with dilute sulfuric acid. Next, we have some confirmatory tests for the anions. So the first one is for the CO3 minus. So take the 0.1 gram of salt in a test tube and add the dilute sulfuric acid. So we have done this. Now CO2 gas is involved with brisk effervescence which turns lime water milky. So this was the preliminary test. On passing the gas more for some time, milkiness disappears. So this confirms that okay, this is our carbonate ion finally. Next, for sulfide ion, we take 1 ml of water extract, make it alkaline by adding ammonium hydroxide or sodium carbonate extract. Okay. Now we add a drop of sodium nitroprusside solution, then a purple or violet colorless coloration appears. So this is an important reaction. This is sodium nitroprusside, and this confirms that okay, we have the SO2 minus. Then for sulfide, which is SO3 minus, we take 1 ml extract of this sodium carbonate extract in a test tube and barium chloride solution. Okay. Then a white precipitate is formed which dissolves in dilute hydrochloric acid and sulfur dioxide gas is also involved. So this is for the sulfur. If this happens, or take the precipitate of step 5 in a test tube and add a few drop of potassium permanganate solution acidified with dilute H2SO4. Then color of this potassium permanganate, which is violet, it get discharged, then it is a sulfide. So this is the confirmatory test for CO3 minus, S2 minus and SO3 minus. Now the remaining one, that is NO2 minus and CH3CO minus, can be confirmed by these two. So if we have the nitrate, then it will confirm by taking the 1 ml of that water extract in a test tube and adding a few drop of potassium iodide, that is Ki, and a few drop of starch solution and acidified with acetic acid. So what do we get is the blue color solution. Or we can do what do we take is the acidify 1 ml of the water extract with acetic acid and add 2-3 drops of the sulfanilic acid and followed by the 2-3 drops of 1-phenylamine. Then the red color indicate the presence of nitrite ion. So all these tests are important because you will get direct questions from here that okay, we have this thing, you do this thing and get this color, then you have to say that which ion is present there. So if you just remember all of this table one by one, then you can do it directly without any second thought. Now for acetate ion confirmation, so we do the thing is that we take 0.1 gram of salt in china dish and 1 ml of ethanol and 0.2 ml of conc H2SO4 and heat it. If this fruity order confirms the presence of acetate ion, so basically the formation of this ester is taking place here. Again, if we take 0.1 gram salt in a test tube and add 1-2 ml distilled water, shake it and filter it well, and add neutral ferric chloride solution to that filtrate, deep color appears. On boiling, a brown red precipitate is formed. So this is a confirmatory test for acetate ion. Now what happens to the rest of those who does not react with this dilute sulfuric acid? We treat those with the concentrated sulfuric acid. So if a colorless gas with pungent smell is appeared, which give dense white fumes when a rod dipped in ammonium hydroxide is brought near the mouth of the test tube, then HCl gas is evolved and it is the possible anion may be Cl minus. If a reddish brown with a pungent order is involved, means the color of the gas is reddish brown and intensity of the reddish brown increases on heating the reaction mixture after addition of solid MnO2. So we add MnO2 and we heat it more, then solution also acquires red color. Then of course it is a vapor of Br2 and maybe Br minus is present. Next is the violet vapor. So if you have some violet vapors which turns starch paper blue, okay, so we know that iodine turns the starch paper blue, and a layer of violet subliminate is formed on the side of the tube. Then fumes become dense on adding MnO2 to the reaction mixture. Again, if we add MnO2 into the reaction mixture, then the fumes become more dense. Then it is iodine vapor, and iodide ion may present. So I minus here. Now, if brown fumes involved, okay, upon heating the reaction mixture after addition of copper turnings and the solution acquire blue color, then it is NO2 or nitrate ion is present in the means nitrate ion is present in the salt. Again, if we have a colorless gas again, an odorless gas, also both colorless and odorless. The first one is odorless, colorless but with pungent smell. But this is both without smell and without color, and it turns the lime water milky, and gas coming out of the lime water burns with a blue flame if ignited. So if the gas that is coming off the lime water is blue, is giving blue flames upon burning, so it is NO2 gas and nitrate ion is present there. Okay, so this both are for the say case of the observation for the preliminary test for conc H2SO4. Now let us see some confirmatory test. So the confirmatory test starts with this chloride. So we take again 0.1 gram of the salt in a test tube and add a pinch of magnesium dioxide and 3-4 drop of conc H2SO4 and heat the gas mixture. Then a greenish yellow green color is evolved, which is detected by its pungent odor and bleaching action. Next, we take 1 ml of the sodium carbonate in a test tube, acidify it with the dilute HNO3 or take water extract and add silver nitrate solution. Then a curdy white precipitate is obtained, which is soluble in ammonium hydroxide solution. Now again we take 0.1 gram of the salt and a pinch of solid potassium dichromate in a test tube. Add a conc H2SO4, heat and pass the gas evolved through sodium hydroxide solution. It becomes yellow. Now divide this solution into two parts and acidify one part with acetic acid and add lead acetate solution. Then a yellow precipitate is formed. Acidify the second part with the dilute sulfuric acid and add 1 ml of amyl alcohol by 1 ml of hydrogen peroxide. So after gently shaking it, the organic layer turns blue. So this confirms that we have the chloride anion. Next, for bromide anion, we take 0.1 gram of salt and pinch of MnO2 in a test tube, and we add 3-4 drops of the sulfuric acid and heat it. Then an intense brown fumes are evolved. Now neutralize 1 ml of sodium carbonate. So we neutralize it with the hydrochloric acid or take the water extract, or we can take the water extract also, and add 1 ml of this carbon tetrachloride or chloroform or this carbon disulfide. Now add an excess of chlorine water dropwise and shake the test tube. So what do we get? A brown coloration in the organic layer form confirms the presence of bromide ion. So this is the confirmatory test for bromide ion. Next, for iodide ion, that is I minus, what do we take? We take a ml of solid salt solution neutralized with HCl and add 1 ml of chloroform or carbon tetrachloride or carbon disulfide. Now an excess of this chlorine water drops and shake the tube, and upon shaking the tube we get a violet color which appear in the organic layer. Now what do we take? We take 1 ml of the sodium carbonate extract, acidify it with dilute HNO3 or take water extract and add silver nitrate solution. Then a yellow precipitate insoluble, which is ammonium hydroxide, is produced. Then for nitrate ion, okay, we take 1 ml of salt solution in water in a test tube and add 2 ml conc H2SO4, okay, and mix thoroughly. Then we cool the mixture under the tap and add freshly prepared ferrous sulfate along the side of the wall, okay, without shaking. Then a dark brown ring is formed at the junction of two solutions. This is your famous brown ring test. Then for oxalate, We take 1 ml of water extract or sodium carbonate extract and acidify it with acetic acid and add calcium chloride solution. Then a white precipitate insoluble in ammonium oxalate and oxalic acid solution but soluble in dilute chloric acid and dilute nitric acid is formed. Okay, now we take the precipitate from test A and what do? Is we dissolve it in conc H2SO4 and add very dilute solution of KMnO4 and warm it. Then what happens is that the color of KMnO4 solution is discharged again. So this potassium permanganate and it is discharged again and pass the gas coming out of the lime water. The lime water turns milky. So this confirms that we have the oxalate. Now the remaining two anion are sulfate and phosphate. So what do? Is we take 1 ml of water extract of the salt. So if we do not get any of those confirmatory tests positive, then we take the 1 ml extract of the salt water or sodium carbonate and then acidifying it with hydrochloric acid and then we add BaCl2 to the solution. Then white precipitate insoluble in conc H2L and conc HNO3 is obtained. Now if we acidify the aqueous solution of sodium carbonate extract with acetic acid and add lead acetate solution, appearance of white precipitate confirm that we have this SO42 minus. At last we have the phosphate. So acidify the sodium carbonate extract or solution of the salt in water with conc HNO3 and then we add ammonium molybdate solution and heat it to boiling. Then a canary yellow precipitate is formed. So this was all for the confirmatory test for the anion. Now let us move first for cation. So for cation, this is the preliminary test for identification. So we have the color test. So if it is having light blue color, then it is Fe2 plus. Sorry, this is for Fe2 plus. Fe3 plus here. This will be not present here, or maybe present. Sorry. So we will let this leave. So if it is blue color, then it can be Fe2 plus or Fe3 plus. If it bright green, then it is Cu2 plus. If the salt is blue, red, violet, pink, then it is Ni2 plus. And if it is light pink, it is CO2 plus. So we can see the color and predict the compound to some extent. Why? Because this color of the compound is mainly due to the metal that is present, means and it is mainly due to any of the our phenomena like metal to ligand charge transfer or ligand to metal charge transfer. So or DD transition. Now we have this dry heating test. So we simply heat this salt. Okay. So if we get white color when it is cold it is blue, and if upon heating it gets white, then it is Cu2 plus. Now if the color is green and upon heating we get dirty white yellow or dirty white or yellow, then it is Fe2 plus. If are initially white and turns into yellow, then it is Zn2 plus, and if it is initially pink and turns into blue, then it is CO2 plus. So this is the initially preliminary test. Now what is flame test? So we take the hydrochloric acid solution of salt and we dip and we put it into our platinum wire loop and then heat it. Then if the color of the flame observed by the naked eye is green flame with blue center and observed through blue glass gives same color as observed, then it is CO2 plus. Now if the color is crimson red and we again observe it through the blue glass and we get purple, then it is Sr2 plus, which is strontium. And if it is apple green and upon this seeing through the blue color glass, it is bluish green, then it is barium. At last, if it is brick red and upon seeing it through this blue glass we get green, then it is Ca2 plus. So this is the flame test. Next, this is the borax bead test. So it is basically for the colorless one, salt. So we take this thing and heat it, then the water of crystallization is removed, and upon further heating this borax, we get this sodium metaborate and boric anhydride, which is B2O3. Now if we have, suppose you have the copper sulfate solution and we treat it with B2O3, then we get cupric metaborate blue green, which is blue green color, okay, plus SO3, which is sulfide. Okay, so we get this complex that is CuBO twice and whole twice. Now two reaction may take place in reducing flame. So this is for the oxidizing flame. So if we do it in the reducing flame, so what will happen? So two reactions can take place. So if it is cuprous and if we treat it with this this thing, now it will give you this thing which is colorless cuprous metabolite. So it is colorless in color. And if it's cupric, it may be reduced to metallic copper and bead appears red, okay, and opaque. So this is the borax bead test here for you. Now for the other salt, colorless salt. So we have different cases, okay. So if you have CO2 plus, then non-luminous flame or the oxidizing flame gives you blue color in cold, and on heating it gives you green. Again, if it is reddish brown, then upon treating it with non-luminous flame, it is giving you violet, light violet to light violet. It does not change its color. Then yellow to yellowish brown. So blue to green means Cu2 plus, reddish brown to violet means Ni2 plus, light violet to light violet Mn2 plus, and yellow to yellowish brown Fe3 plus. Now if it is luminous flame, again if we do it with the luminous flame, so if it red opaque turns to colorless, then it is again Cu2 plus, and if it gray to gray, then it is Ni2 plus, color to colorless, it is again Mn2 plus, and green to green means Fe3 plus. So this is the borax bead test. Next is the charcoal cavity test. So we add the salt and anhydrous solution of sodium carbonate in charcoal block, okay, then weight it with water. Again we heat it with the blowpipe. So what do? We take the candle and we blow it with the pipe against your charcoal block cavity. So suppose we have a CaSO4, then we are treating it with this anhydrous sodium carbonate, then it react to form this copper carbonate. Now copper carbonate on heating gives you cupric oxide, okay, sorry, cupric oxide, and again on heating it gives you red color copper. Now suppose if it is ZnSO4, then ZnSO4 on treatment with Na2SO3 gives you ZnCO3, okay, and ZnCO3 upon heating gives you zinc oxide plus CO2, which is yellow when hot, which is yellow when it is hot, okay. So for different remaining cation, for Pb2 plus, yellow residue when it is hot, and when it is cold it turns into gray metal. For arsenic, white residue, okay, and with odor of garlic, means it is having a smell of garlic. If it is scandium ion cation, then we get the brown residue, and if it is zinc, we get a yellow residue when it is hot and white when it is cold. So this is the charcoal cavity test. Next we have this cobalt nitrate test. So we take the cobalt nitrate and heat it to get cobalt oxide, and treating the cobalt oxide with the salt ZnO, we get green, okay. So this is the cobalt nitrate test. Now we'll see some questions here to see that we have whether we have covered the syllabus or not. So a compound liberates say NaHCO3 and CO2. So this is this is CO2 and this is NaHCO3, and also gives colorless FeCl3 solution. Okay, so this two criteria are fulfilled. So if this is these two are filled, means it is having a carboxylic acid, and if it is giving color with neutral ferric chloride, then it is having a phenolic group. So it must be this, that is B. Okay. Next, in an organic analysis, the reagent 2,4-DNP hydrazine is used for the detection of which of the functional group. So it is for amines basically. So we have seen this. A nucleophilic aromatic substitution takes place and we get this 2,4-DNP test. Okay. Next, in the kinetics study of this reaction of iodide and hydrogen peroxide, a known volume of sodium thiosulfide is added. Okay. So the given experiment looks like this. Okay. So we have the tetrathionate ion. Which of the following gives blood red color with KCl? It is Fe3 plus. So this is the reaction. So Fe3 plus gives you blood red color. Now the brown ring test is due to the formation of which complex? So it is due to the formation of this thing, CN5. Sorry, NO2 plus. Okay. So now these are the questions you can try by yourself.